in this video, we'll be starting the study of the second type of improper integrals. In the first type, we looked at bounds that were infinite, so values of x that were going to infinity. In the second type, we'll be looking at values of y that goes to infinity, so vertical asymptotes in your graphs. The first thing I want to do is just do an example of what could go wrong if you ignore that there's a vertical asymptote, what could go wrong if you ignore that is an improper integral. So I want to solve this problem. I want to look at this region bounded between secant squared and 0. So the blue line is secant squared, the black line is 0. I want to set up an integral for the area of this region, and then I want to evaluate the integral, and I have this weird question, what is wrong? So this is clearly a trap. Let's ignore that and just do it as if we didn't know, and we'll see what goes wrong in the end. Alright, so I'm given y equals a function of x. I'm going to use vertical slicing. Everywhere I look, top will be secant. So from 0 to pi, top is secant squared. Bottom is 0. So I get the integral of secant squared of x dx. Alright, let's evaluate this integral and see why I claim something's wrong. The integral of secant squared is tangent. I'm going to go from 0 to pi, so I'm going to plug in pi first. Minus tan of 0. Pi is this angle. Right? I just wanted to make sure I was split. Pi is this angle. The slope is 0, so tangent is 0. And 0 is the same line, so both have slope 0. I get 0. The computation tells us that this blue area is 0. And that makes no sense because even if my graph is a bit off, the minimum height is 1 and the width is pi, so this must be at least pi, and frankly it must be more. And so something's wrong. So something I did is not legal, and it's not legal because I have an asymptote here. And the step that I'm not allowed to make is strangely this one. Here I'm using the fundamental theorem of calculus, and for me to be allowed to use it, I need a continuous function on my interval. This function is not continuous because it has a vertical asymptote. It has an infinite discontinuity. So let me just remind you of that statement of FDC. So we're told in FTC that if f is continuous on your interval, then if you're trying to integrate f, you should plug in b and a into an antiderivative. So g is any antiderivative of f. This is the point that stops us from using FTC. Alright, so to be allowed to use FDC, your function must be continuous on the whole interval. So you cannot have vertical asymptotes. You cannot have jumps. You can't have points where you have to lift your pen to draw it.